All right, so we are going on to the next section, which remember is ratios, proportion, rates, and unit rates. And remember, we are going to our old textbook, even though it says 7 honors, it's just the regular notes. I just stole these from Mrs. Levy. It's the same notes we used in regular. And we will go back to our textbook in a few weeks. So we are talking about a ratio. That's a word we talked about in class today. Is a ratio is a comparison of two like quantities by division. So when you write a ratio in math, you can write it 3 different ways. You can use a colon, 30 colon 3. You can write it as a fraction or a ratio, 30 over 3. You could also use the word 2, 30 to 3. So that's not on here, but you could do that also. Okay, and I'll write it in for you. Or, I don't know why I'm doing 30, it's 90, 90 to 3. Okay? So like we said already, a ratio is a comparison of two quantities by division. If I scroll down here, in one rectangle, the ratio of the shaded squares to the unshaded squares is 7 to 5. That's this top one. And in the next to it, the ratio is 28 to 20. Both rectangles have equivalent shaded areas. Ratios that make the same comparison are equivalent. Therefore, not 7/5 is equal or equivalent to 28/20 because they both take up the same space. They're just broken down into different pieces, different number of pieces. Okay, so they want us to give two ratios that are equivalent to each given ratio. So you can always reduce if you can. So 9 over 27, if we reduce both of those numbers by 9, we get 1/3. You can also take 9 over 27 and multiply the numerator and the denominator by the same number. Or you can take now the reduced 1/3 and multiply that by the same number. So you could have 3/9. Okay, you could add a 0 to both. You could have 90 to 70ths. There's an infinite number of possibilities. Okay, then 74/24ths, we can divide those both by 8. That would give us 8/3. You can multiply that both by 2. You're going to get 16/6. Again, infinite number of possibilities. So you may have come up with different ones than I did. Ratios that are equivalent are said to be proportional or in proportion. Equivalent ratios are identical when they are written in simplest form, meaning these all reduce, if we look at these, these examples up here all reduce to 1/3. Okay, same thing here. These all reduce to 8/3. All right, simplify to tell whether the ratios form a proportion. Okay, so what you can do here is you reduce both of these. 2/18 reduces to 1/9. Divide them both by 2 and divide these both by 3 and you get 1/9. And since they reduce to the same thing, yes, they are proportional. Okay, so 12/15, we can divide those both by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. 27, so I divided these by 3. 27 and 36 are both divisible by 9. 27 divided by 9 is 3. 36 divided by 9 is 4. So those are not equal. These are equal. So this would be no, those are not proportional. Okay, so you could also do this. 2/3 equal to 4/9. What you do is you cross multiply. 2 times 9 is 18, 3 times 4 is 12. Those are not proportional. Okay, if you do 2/3 and 6/9, cross multiply, you get 18 and 18. Those are proportional. So whichever way works best for you is fine. Okay? All right, so here's the next one. Now it says, Kate poured 8 ounces of juice from a 64-ounce bottle. Brian poured 16 ounces of juice from a 128-ounce bottle. Are Brian and Kate's ratios proportional? Okay, so we need to come up with some words here. So we're going to have poured over total. Okay, so we need to keep them together. So Kate poured 8 ounces of a total of 64, and Brian poured 16 ounces of a total of 128. Okay, so those are kind of big numbers to cross cancel, so I'm going to reduce them. 8 and 64 are both divisible by 8, so that's going to be 1/8. 16, let's divide by 2 first, or by 8, excuse me. 16 divided by 2 is 8. 128 divided by 2 is 64. 2 divided by 2 is 1. 64 divided by 2 is 32. So no, those are not proportional because when we reduce them, we do not get the same reduced answer. Okay, I need to go back to this one real quick because I just realized that I made a mistake. Okay, so what I just said here, I divided the top one by 8 and the bottom one by 2. So let's fix that. So if we divide these both by 8, 16 divided by 8 is 2. 128 divided by 8, I apologize, is 16. And then that does reduce to 1/8. So my answer would be yes. Sorry about that. Okay? All right, so let's go down here. A television has a screen width of 20 inches and a height of 15. So we're going to do width over height. So we have 20 inches over 15 inches. What is the ratio of the width to the height of the screen? Okay, so we're going to reduce that. 20 and 15 are both divisible by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. So you're going to get 4 inches to 3 inches for width to height. Okay? Because we needed to reduce that. All right, now down here, a rate is a comparison of two quantities that have different units. And we talked about this yesterday. Well, actually today earlier. Ratio is the same units, just like up here, width and height. We had them both in inches. If this is a ratio, whatever these units are, even though they didn't give them to us, they have to be the same units. Inches, feet, centimeters. A rate has different units. I gave you miles per hour as an example. I gave you dollars per pound as an example. Okay? And then a unit rate are rates in which the second quantity is 1. Meaning, right now you can get gas for about $1.77 per gallon. My denominator is 1 gallon. Okay? Or you go to the store and you buy something, lunch meat, say, for $2.50 per pound. My denominator, again, is 1. So unit rate, uni, means 1. So every time your denominator is 1 in a unit rate. It's a bad one. Okay? And there's some more examples here. Okay, the bar graph to find the unit rate, Ellen's words per minute. So Ellen has 176 words in 5 minutes. So if we want our unit rate, that means our denominator is going to have to be 1. So we need to do 176 divided by 5, and that gives me 35.2. Just 15, 2 left over. That's going to be a 5, which is 25. 1 left over, add a decimal point, there's your work, and you're going to get 2 left over. So it's 35.2 words per 1 minute. Okay? All right, next. Okay, now we have unit price. The unit price to compare items. Okay, so this is like if you go to the store. Is it cheaper to get the big pack of 15 at Sam's Club, or is it cheaper just to go to the drugstore and get a smaller pack? All right, so here we go. Price per package. So pens can be purchased at $1.95 for 5, or they can be purchased at $6.20 for 15. Okay, so we need to do. Okay, so now I did the work over here on the side. So $1.95 divided by 5 gives us about 39 cents per pen. Okay, so that's 39 cents. 0.39 or 0.39 is 39 cents per pen. Okay, and then 620 divided by 15. Now, it doesn't come out evenly, but once I get to 41 cents and I know I have a remainder, I know that this is more expensive. So this is going to be 41 cents per pen. So in this situation, it was actually cheaper for you not to go to Sam's Club or Costco or any of those big stores that sell stuff in bulk. It was actually cheaper to buy the small package. So which is the better buy? In this situation, the better buy would be the pack of 5 pens, because you're only paying about 39 cents per pen, so you're saving yourself about 41 cents a pen. Okay? See you tomorrow. That was the end of the notes.